Hello everyone. Good afternoon you all. Now, today Dr. Nikhil Dhawan from IIT Roorkee is with us, and he is going to speak upon the e-waste and their effects on that and how it will be contributing to the waste manage and their management also. Now let me introduce and the next forthcoming talk by Dr. Felix Past at 3:30 p.m. Now I'll introduce about Dr. Nikhil Dhawan. He is an assistant professor in the Department of Metallurgical and Materials Engineering at the IIT Roorkee. Obtained a BE in Metallurgical Engineering with first class honors from PEC, that is Punjab Engineering Agri College, Chandigarh in 2008. He did his PhD from the University of Utah in 2013. He is working in the areas of recycling of electronic waste and ores for recovery of valuable and precious metals. He has four sponsored research projects funded by the various government organizations and has authored 47 journals, 20 international conferences, and 2 book chapters. He is elected as a member of the INEAS, that is the Indian National Young Academy of Sciences, and received the AC Datta Misa Award by Institution of Engineers in 2016 and Khare Award 2016 from the Indian Institute of Mineral Engineers. He is a worthy recipient of the MEI, that is the Mechanical Engineering International Young Persons in 2019. Now I hand over to Dr. Nikhil.
So just let me share my slides. Actually, I think it is saying you need to shut your screen off. Okay, it is saying you cannot start screen share while the other participant is sharing.
Yeah, it has been taken over. You can do that now.
Okay. So are you able to see my slides?
Yeah, it's perfect. You can make it full screen and start your presentation.
Yeah. Is it full screen? Is it visible to all?
Yeah, it's perfect.
Okay. So I will start now. Good afternoon to each and everyone. Okay, so I am going to talk about on the topic recycling of electronic waste, which I feel is probably one of the most important topics, which is not well practiced in India, but is a very well known phenomenon as well as technique being followed in rest of the world. So moving on, what is electronic waste? So we call it anything which is discarded, old, obsolete, rejected electronic gadgets, such as computers, laptops, mobiles, television, printers, etc. It constitutes almost 8% of municipal waste and is one of the fastest solid waste fractions throughout the world. And we should always remember that today's electronic gadgets may become tomorrow's electronic waste. Now, what is happening throughout the world is there are technological upgradations in the world, which leads to enhanced demand. Therefore, we are ought to buy more and more electronic items, and generally they are being carried as we are generating e-waste, and it is accompanying what we call it is going into the landfilling or it is going into the circuit of informal recycling. So what we can do, so there are a couple of sources of electronic waste. If you look at it, can be from home, such as computer, laptop, television, mobile phone, washing machine, whatever the regular day-to-day gadgets we are using. Even in hospitals, computer, microscope, monitors, incubator, X-ray machines. Then in the government sector, same thing. So you name a sector, whether it's a government or a private, you will get plenty of electronic waste. Now, on the bottommost slide section, so what I am trying to convey is that at present in this pandemic area, almost 7.4 people are globally online more than what they are at offline, and more people are always online, so they are seeking more gadgets and devices, and simultaneously there is drop pricing of these gadgets because demand is extremely high, and we all like to have multiple ownerships. So in short, everything is contributing towards the waste generation. So we need a recycling techniques for that. Now looking at the global scenario, the global e-waste generation in world is around 52 million metric tons in 2020. India alone produces close to 4.5 million tons of metric waste and is fifth in the world. So if you look at 2016, 44 million ton waste generation was there, and it represents almost 4,500 Eiffel Towers. Can you imagine 4,500 Eiffel Towers? So huge amount of electronic waste is being generated. So we have to take care of that part. Then I am just discussing with you a very typical study from China, that is electronic disaster, what we call. So in aquatic system, what is its consequences of electronic disaster on aquatic system? The presence of 10 poisonous metals such as lead, tin, mercury, cadmium, etc. This was an acidic stream which is enough to disintegrate penny in few hours. Okay, not in months, in hours. And the concentration of lead is zero point 0.4 parts per million in river water downstream. That is more than 8 times higher what is being considered as safety limit for that water. In air sample, it has shown the production, or let's say availability, of polychlorodibenzodioxins 65 to 2765 grams per meter cube, which is highest level of atmospheric dioxins ever reported in similar samples. And more importantly, there was very high aerial concentration of particulate matter, which we all know China and India had been struggling from couple of years, along with chromium, copper, and zinc content. These are generally, some of them are categorized as heavy metals. And in talking about the human scenario, 15 to 56 times is dioxin exposure, and 7 out of 10 children born have more than 50% lead in their blood sample. So this is a huge alarming situation. 88% of the population suffer from neurobiological, respiratory, digestive abnormalities or skin diseases, and elevated levels of chromium 0.094 parts per million in umbilical cord blood from infants, the newborn babies. And last is even chromosomal aberration. The genetics part is also 20-fold aberration or deviation is being found. Why it is so? Because if we take any component of electronic waste such as PCBs, there is a solder amount into that, that is lead and tin generally, and it has some serious effects on our nervous system, circulatory system, kidney. Then if we talk about resistors and semiconductors, cadmium is present in them, that can lead to neural damage. Relays and switches in PCBs. So even if you open up your TV remote, or even if you open up an AC remote or any electronic gadget, you will find a PCB. And there is some mercury also involved in that. Then is corrosion protection of, let's say, galvanized steel plates, decorator, hardener for steel housing. It has chromium into it. Then the plastic material, whatever desktop or laptop we are seeing, there is a layer of plastic generally onto that. So it contains brominated flame retardants, which disrupts our endocrine system functions. And these days, this is very important. The CRTs, cathode ray tubes, the older monitors, which were quite bulky, now they are being replaced by LCDs, then now is LEDs. It used to have barium, phosphor, and heavy metals. I remember in 1970s, people were still struggling with black and white television. So suddenly it popped up that okay, color televisions came into the house. I remember when I was also child, we used to feel so much happy that okay, color TV is there. So what brings color into them is phosphor material. What we call phosphor is nothing but it contains rare earth compounds into that, along with barium and heavy metals. So it also has some problems related to muscle weakness, damage to heart, liver, and spleen. And motherboard, right, in all the computer devices we have, it has beryllium, which is somewhat carcinogenic in nature. So with all these elements, if they are present in these electronic devices and if they are not recycled well, the fate of them is either they will go into the landfill, or they will be incinerated, or they will be just occupying the space. Now, this is since I thought, okay, I am from Chandigarh and I should share few facts about Chandigarh. That is average e-waste generation in household in Chandigarh. So if you look at the lifespan on the y-axis of different components like refrigerator, television, washing machine, air conditioning, computer, laptop, mobile, CFL, The average age is close to 12 years for refrigerator. For AC is 11 years. Mobile is probably 3 years. CFL is 2 years. Now this data is collected for the last 10 years and is statistically done for the same. Now I feel with the coming upcoming decade, the number will fall more. So instead of 12 year, it may up to be 8 or 10 years. Okay. So where all these materials are going to be there? So this is the landfilling area occupied by these particular units. AC is 40% landfilling area is required for its storage or its discarding. Washing machine followed by CFL and mobile. Mobile is okay. Another thing is with more upcoming technologies, the mobile phones are becoming sleek and the components are getting reduced. So that is why its area is getting smaller. Now, this is the financial calculations based on that. So, we have considered only three elements. AU is gold, silver, and palladium, and the units are kilogram per year, that is NM. So, if we talk about the large household appliances, gold is contained 0.024, silver 0.272, followed by palladium. So, total mass in Chandigarh is almost 7.7 kilograms of these material per year, and if we are not recycling them, which is the real case, we are in fact having a monetary loss of 40 lakhs per year. So that means if you will recycle them well, beyond the, you can save the land space, you can also get some monetary benefits. So that is why it is being carried out in different parts of the world. And even since I am member of Niti Aayog task force for electronic waste, so we are coming up with a proposal that all these can be set for different states and they are being forced to come up with recycling plants. Now, this is what I call the recyclable e-waste. So in the center of the slide e-waste, you can look at, there are screens, cell phones, calculators, any electronic device. So we are categorizing hard disk drives, printed circuit boards, small components like capacitor, resistors, etc. Batteries, like in laptop, whenever you go for purchasing a laptop, the first question will be, you want 6 cell, 9 cell, what is the RAM, what is the hard disk? Nobody bothers where it will go at later stages. Then another part is for lighting is compact fluorescent lamps. Now it is being replaced by LED in coming times. Then is integrated circuits, very important part. Then is RAM, how fast your system can work, right? You want what RAM you want. Then is CPU, smaller parts, that is central processing units, which controls the complete software part for that. So these are for us, these are not the computer parts. We view them as urban mining, the great source of metals. So we get base metals, copper, iron, nickel, tin, lead, cobalt, manganese, and precious metals, gold, silver, palladium, platinum, and most importantly, rare earth elements, that is neodymium, dysprosium, yttrium, cerium, terbium, europium, lanthanum. So, are there ways to extract all of these materials? Definitely yes. Now moving on, so there are a couple of problems. First of all, environmental aspect is there. So landfilling is not a foolproof area. That is why, because it contains, let's say, it releases a lot of toxic gases over passage of time, and then is presence of heavy and harmful elements like chromium, etc. So if you keep them longer in the means land oceans area, they may seep through. Then is the human health issues. Most importantly, another problem is collection system. It is very difficult to recycle, to put a simple recycling plant for all type of waste, because it varies with the manufacturer also. Then there is a heterogeneous nature of electronic waste. No two systems are same unless and until the manufacturing company is same. Then how you will reduce the particle size of such material, because plastic is highly ductile, okay, and metals are also ductile, and in some cases some brittle components are there, so it is very difficult to grind such material. So there are special type of impactors as well as cutting mills available. And another thing is presence of unwanted material or matter. In this case is carbon, bromine is generally used in these flame retardants, right? For example, we always complain HP gets warmed up, the laptop is very warmed up whenever you use it for longer time. So such things, generally flame retardants are being put so that the system does not get at very high temperature and it should not fail. So general purpose motivation is compared to respective primary ores or sources, e-waste contains 10 to 20 times higher concentration of these metals, 30 to 40 percentage metal followed by non-metal part. Only 20% e-waste is formal recycling through registered waste recyclers. 80% goes through informal recycling. So I will discuss why it is so. So the recycling purpose is minimal or no usage of acids, what we call prior removal of this organic matter, carbon as well as bromine, separation of metallic values, and a process should be there for environment friendly as well as cost effective. So another means we have done some kind of a systematic study that is to know what population part is aware of e-waste. So there are different parameters onto that. First is knowledge on e-waste. So out of 250 people, they reported 31 were not aware of what is e-waste. Means sorry, they were aware of e-waste activities. Almost 69 were not aware of. Knowledge of hazards probably informed is 30% only same. They were rest were uninformed. Knowledge on e-waste handling rules as imposed by the government in year 2011 only 12%. So then is exchange policies. 20 were interested. Rest it is said they have never considered even. Then is even in Chandigarh also in other places there are e-waste bin collection systems also. Only less than 10% are aware of that. 90 say we don't know even. Then is e-waste bin for disposal of gadgets. Like people are getting aware of problems of, let's say for example, these batteries. Okay, what we call double A or triple A batteries. Now they are aware that they have to use it. They have to then discard it into separate chambers and or give it to agency. So only 2% are aware of that. So in short, most of the population is unaware of these challenges, that okay, how e-waste can be reused. And unfortunately, we are one of the hubs. India is one of the hubs along with China to get all the European electronic waste. And what we are doing, we are just segregating the materials, and then it is being shipped again back to Europe for a very good grade material which can be recycled there. So this is what we call informal processing. So I, along with my group, have visited couple of sites. So there are two main places in India where this informal recycling occurs. One is in Moradabad, Uttar Pradesh, and second is in Delhi, Old Delhi. Okay. So circuit boards are fired openly, cable burning in open as such, second figure, and then is toxic gases are going on as a smoke. These workers are very happy because they get livelihood for a couple of months, but the long term problems, health problems they occur is unextinguishable. Okay, so that is very crude manner of doing these things. So if you look at this person is just burning on the circuit board on stove, and huge flame is coming up, and rest at the end of the day he will get copper as well as tin material only with it. Some are doing acid stripping, so they dissolve as such printed circuit boards in highly concentrated acids. Okay, metal will get dissolved as you can see from the green color, copper mainly. Rest of the metals will remain as such, and then it is what we call simultaneous leaching. All metals will start getting dissolved, and it is very difficult to isolate these metals with passage of time, and the residue is highly corrosive. And then last is cracking and dumping. So people are just trying to disintegrate into valuable parts and plastics. Valuable part is being restored again, and it will be then shifted to another smelters in Europe. So what I call the formal recycling, this is what means we among Indian population is doing also some portion of that. So we start with electronic waste. It should be dismantled. Plastic should be separated. Then is size reduction. Then you have different recipes: thermal processing, hydrometallurgy, bioleaching. Why? Because you have already separated the plastic fraction. And then is the physical processing. Among all of them, this is physical processing is the best, because it says you are trying to classify the material based on density, based on magnetic response, such as iron and steel parts can be removed. Then it's electrostatic, which can help you to yield aluminum and copper. Now this is very exciting population means practice bioleaching. So we are making use of different type of bacteria here. which can reduce different species of metals present. Generally, it is well adopted for copper and gold. And then once these bacteria can survive in that temperature, so we call it thermophiles, they can survive in that media, they can leach and they yield you the metal extraction. This is one of the very good areas, and I feel India should be going well along in this line. Hydrometallurgy, the acid part, then after the dissolution, you put solvent extractions, and then you electrodeposited the material or the metals from that same for further application, copper as well as tin. And then thermal processing, this is what Europe is following. Pyrometallurgy, they feed all this printed circuit boards into a converter which is operating at 1450 degrees Celsius, and they use it very successfully. The reason being because these printed circuit boards contain good amount of copper, 30%, and copper is a scavenger for gold. So wherever copper will go, gold will come automatically with it. So that is why they are using it very well. So prime purpose is copper, but the majority of the process value comes from the gold. So this is going to be a huge industrial area that is going on. So now how we can channelize the e-waste? So if you look at the manufacturer, then it goes to retailers, consumers. So what is our role? So consumers have an option, waste management. We have to look at either there should be a collector, a recycler, or refurbisher. Now if you look at the leading companies like Apple, etc., they have all this policy. They can sell the refurbished iPads, iPhones, etc. Now after the end of life of these particular devices, they have options: landfill, incinerator, okay, burning at very careful conditions, or they can be exported, or they can be refurbished, or they can be recycled. So out of these one, I will say the best option is recycle for India, because it goes well in the line of, okay, Swachh Bharat, Make in India, everything can be done provided there is good support from different places. Now I'm sharing with you some of the key countries' issues. For example, Switzerland. In Switzerland, consumers pay the recycling fee, which is equivalent to the difference between the total system cost and the recovered cost, well beforehand. The fees are collected in advance, okay, at the time of purchase. So in this case, the system leaves no illegal disposal of the e-waste. Okay. So the consumer is responsible for his efforts. In Japan, they say, okay, consumers ensure separation of e-waste from municipal solid waste. So there are different bin systems into which e-waste will be thrown away. Consumers have to pay an end of life fee that covers part of recycling. So during the purchase itself, they will add this amount. Now, the retailers are required to collect and transfer discarded product from consumers. So we believe consumers can also be given more responsibility for e-waste disposal if resources for proper recycling are readily available to them. So that is correct. If you have more recycling efforts going in the country, everybody would like to contribute towards that and will go for that. So that is what we call formal recycling. So the challenges are informal recycling sector development. Consumers refuse to deliver their obsolete electric and electronic equipments without financial incentive, right? It is same for me and for you also. Means we will always try to store obsolete products by assuming that, okay, it will have some future value. The parts can be used somewhere else. But now this is not, the current era does not allow to do so, because we have to recycle it. Otherwise, it will take more and more space and health associated hazards with it. Now, another thing is economic motivation, financial incentives. If you put up a cashback or discount coupons with recycling, I feel this will go in a long way. And then is environmental incentive should be there. Donation of e-waste to an organization in return for tree planting. These are some of the ways people can go for. Now, this is one very good solution. So if you look at, it says do not trash. Engagement is in collection, recycle. So people have put up these kind of devices. They dump their mobile phones and sleek electronic devices into that. Recycling agency comes and they will just take away all the material and it is being fed for recycling. So some companies, example Baidu Recycle, have started, they have make up an app. They will, you just log in with your details and say, okay, this much electronic waste is there. So they will take it from your home within 1 to 2 days and it will be recycled. So this is one of the ways. So in short, we call it as eco ATM. Instead of money, it is like eco-friendly devices. Okay. So you put their material, your material, and will be taken care by a registered recycling company. Now, in the last part of my talk, I am going for very specified the scientific part for one of the key applications, rare earth elements. Uh, I hope, just like me, all of you must be aware that when we were in class 9, 10th, 11th standard, in periodic table, there were lanthanide and actinides. Those were present at the bottom of the periodic table. And everybody used to say organic chemistry is important. I will say, in fact, whole periodic table is very important. The reason being, these rare earth elements at the bottom of the periodic table, two lines, they have numerous applications. So I will start with magnetics. So your computer hard disk drives, or even your speakers or your headphones, microphones, they have magnets into them which are made up of neodymium, europium, gadolinium, praseodymium. These phosphor, these CFL lamps, they have rare earth elements inside. So they are made up of glass. Inside glass, there is a coating, phosphor coating, what we call. So these consist of rare earth compounds into that, and CRT as well as LCD liquid crystal display into that. So next is rechargeable batteries, right? NIMH batteries. Whenever we talk about camcorders or walkie-talkies, or in these days electrical vehicle batteries, like example Toyota Price, just an example. So if you look at all these components, LCD screen, polishing powder, glass mirror, UV cut glass, diesel fuel additive, battery, most important, catalytic converter, one of the key components, motors, headlight glass, all of these constitute rare earth in their respective compounds, which offers numerous properties and applications, such as they fluorescence strongly, then they have very superior magnetic properties, very high electrical conductivity, very high melting and boiling points. And but the key issue with them is, as the name suggests, rare earth. Rare earths are not as rare as their name implies, but it is very difficult to extract and mine them because they occur in a very dispersed concentration, and they are always like brother sister together. This is because they have very similar chemical properties, and this can be attributed to their electronic configuration. Okay, the unfilled shell, what we call it here. And then they have variety of applications in what we call renewable energy, wind energy, for example. To build 1 ton, to build one wind turbine, we need almost 200 kilograms of rare earth elements. Can you imagine 200 kilograms? So I will show you, to get 200 kilograms, how much raw material is required. So these are the typical rare earth elements in the periodic table: yttrium, gadolinium, terbium, up to lutetium. And second is low rare earth elements. And the application, this is the horseshoe magnet which is being used in hard disk drives, what we call NdFeB, and the formula will be Nd2Fe14b. To synthesize such a particular alloy system, it took 1 decade to manufacture this material. Similarly, for NIMH rechargeable batteries, what we call AB5 batteries, then is phosphor. So there is significant concentration of rare earth elements being used in these one. And these are their primary sources. Monazite, it contains only 4 weight percent. That means if you take 100 parts, you will hardly get on average 2 parts. Rest 98 is impurities. So we call it that why rare earth is an issue. They are not concentrated in economical viable quantities, very difficult to extract for profitable purpose. They have very similar ionic radii. That is why they are difficult to extract and recover from chemical perspective. Now, the major application what I want to highlight with you is lamp phosphors. Okay, so there are 5 main rare earth phosphors. So what I'm talking about, for example, these are the lamp phosphors. As you can see, this is glass outside, and inside glass there is a white coating onto that, that is called phosphor. And that phosphor is having any 5 of these components. It can be 1, 2, 3, 4, 5, depending upon the light and lumen intensity you want. So if you look at where are rare earth elements, they are being doped, like europium, terbium, cerium, and in this case cerium, terbium, europium. So they are doped. So concentration is somewhat low. So what is the challenge? Beyond these rare earth elements, these tubelights have pressurized, or the vapor mercury, what we call, it goes up to 5 to 6 parts per million. And then the rare earths occur together, so it is very difficult to isolate them. Then along with the release of the mercury vapors, so that is why whenever a tube light is broken, there is a very shriek noise coming onto that. And then you have to look at the crystal structure, because it took almost 6 years for researchers to find out that what is the best crystal structure available among these material, so that it becomes highly thermodynamically stable. Now we are doing reverse engineering. We want to pull out the rare earth elements from recycling. So that is why we look at these crystal structures and estimate how much energy and why it is taking so much energy for these ones. So it's a huge challenge here. So in short, in this case, if you look at, this is a particularly rock for that monazite or xenotime. If you want these concentrated powders, this is one way. And the second source for these powders is lights, or these lamps or tube lights. So we have done some calculation. It shows 50 kilogram of these ores. And please mind it, this ore is very, let's say, densely populated in China. But in India, only on our victories map, that is on the bottommost portion of the map, if you see there is a V sign, you can only get this material over there. And it also means falls under the atomic agency. Okay, it is not that somebody can go and get that material. No, you have to take permission from Department of Atomic Energy. So roughly 50 kilogram of ore, or if you take around 1500 units of these tube lights, virtually you will get this much material. So I feel this is further easier to get it, provided you take care of mercury. Now these are some of the headlines for that. So Delhi is struggling to dispose the few CFLs. As of today, I know 2 million units are lying in Delhi for recycling purpose, but there is no process available. In Kerala, same e-waste is a huge issue. Then at Bengaluru, bright but toxic. If you look at these all categories, so there is no process to handle. So in Canada, somebody has come up with an idea of to remove a mercury. In fact, our lab at IIT Roorkee, we are designing what we call a bulb eater. So you put up your bulbs in that particularly drum, in which there is a shredder come impactor into that, and we put up a HEPA filter on the top. So mercury is being adsorbed onto that filter, and the rare earth which gets crushed, or the phosphor which gets crushed for the recovery of rare earth, is being further treated. So we are on the line of doing that research. Last time, moving on to the another important category. So up to now I have covered PCBs, then I have covered the phosphors. Now I'm coming on to the lithium ion batteries. So base metal, copper, etc. we have done. Then we have done rare earth. This is another category of metals, what we call critical metals here. Why? So lithium ion batteries have potential application in portable electronics such as mobile phone, laptop, right? On the right hand side, there is this cell. This is generally from your laptop. So when we go to a laptop seller, he will always ask, okay, you want 6 cell, 9 cell. So this is one cell out of that. And if you look at it, consists of anode, separator, cathode. Anode is copper okay, sheet, graphite is coated onto that. And then on this cathode side, on aluminum sheet, you have a cathode material. This is a complex compound of this system, lithium, cobalt, manganese, nickel, generally oxide form. It is being coated on the aluminum. Now, these batteries are also being considered to be used in hybrid vehicles, in aerospace applications also. Worldwide, 33 billion LIBs are used. In India, we have 1 billion batteries available. EV market, with coming up EV market, this demand has to be increased tremendously. So we expect massive accumulation of discarded lithium ion batteries. At present, it is 2 million metric ton per year, huge number. Key issue is heterogeneous chemistry. If you take up an Apple battery, you will not get manganese into that. You take a Samsung battery, there is no nickel. If you take Chinese battery, everything will be there. So based on that, some sorting as well as segregation needs to be taken care. Now, another issue for India is that there is no primary production of lithium and cobalt. If you don't have lithium and cobalt, virtually it is impossible to synthesize a lithium ion battery. That is why the cost is very high. And if you open up most of the batteries, it will be written as made in Korea, Japan, okay, Singapore, etc. Very less in India. Now, from the last couple of 2 to 2.5 years, it is going very well. So we have estimated 4,000 ton of discarded batteries can give you 1100 tons of heavy metals such as cobalt, okay, manganese, nickel, iron. Then 200 tons of toxic electrolytes, generally LiPF, F6, HF, etc. are there. So the composition is lithium is 2 to 8%. If you're talking about the primary ore of lithium, it will be 1%. So it is very enriched source. Cobalt, there is no primary production, but in these batteries, you may get 5 to 20, manganese 5 to 10, nickel 5 to 10 organic compounds. So the if I talk about the economic aspects, cobalt is the cheap, means expensive one, followed by lithium. Now, cobalt has another problem. If you want real cobalt, you have to go to a country called DRC Congo in Africa, where the child labor is being extensively used. So all these recycling companies have decided they will only use the material which is recycled. Apple has this statement. Even if Apple has another robot called Daisy, which can just crush your cell phones and can segregate all these metals within couple of hours. So it's a huge challenge. So these are some of the existing techniques what we and others follow all across the globe for whether you can go pyrometallurgical industrial operation against smelting. So you put all the material, you create such conditions in the reactor that you will get an alloy, the heavier metals, and slag, the lighter metals, lithium and aluminium. Another part is hydrometallurgical. Two plants are running in India. One is in E-Parisar, Bangalore itself. They are doing this hydrometallurgical part. But based on my experience at different levels, I feel a process should be combination of both, because here you are losing lithium values in the slag, and lithium is highly required for lithium ion batteries for us. Whereas in hydrometallurgical, the whatever resulting water or solution we are getting, if it cannot be recycled back into the system, it is again waste generation. So this should be avoided. Then next, I will conclude that e-waste has emerged as one of the fastest growing waste stream throughout the world, and it is one of the most effective. Recycling probably is the most effective solution to the growing e-waste problem, and is beneficial not for economical purpose but for resource conservation as well as environmental aspects. You can extract valuable metals such as copper, gold, silver, palladium, and rare earths from these streams. Effective e-waste recycling promotes Swachh Bharat, definitely Make in India, and probably will be well aligned with Atmanirbhar Bharat in the coming times. So next, I will say a very thank you to all of you for patient hearing, and I will be more than happy to answer any of your queries. Thank you.
Yeah, thank you so
Yeah, it's okay.
Thank you so much, sir, for sharing your such a valuable talk. And it's more about the e-waste and how to reduce and recycle the e-waste. And now I over to Dr. Felix.
Kriti, I think I didn't hear you. Nikhil, can you hear me?
Yes, I can hear you.
Perfect. Did you hear Dr. Kriti?
Uh, Somewhat not clearly, but
Not clear. Okay. I think
yeah,
you had to fix. I don't know what is wrong with that. But anyway, yeah, it's a wonderful session, Nikhil. It is absolutely, you actually highlighted the dire necessity of the e-waste and the segregation, and you have covered a lot of points. Honestly, I was not at all aware of any of these things. You have really opened up, many of commoners like us, the importance of the e-waste management. So it's an amazing session. Thank you so much for accepting our invitation.
yeah,
And
thank
in
you.
earlier session as well, we got so many questions on the e-waste, while the people, the speakers were not really expert on the e-waste management. So we were deferring those questions to this section. So yes, so we are getting a lot of questions from the participants. So we have so many questions. So let me pick up one question here.
Yeah.
This is Arjun Potia from Sikkim. Arjun is asking a question. Before attending your talk, I read an interesting article in Down to Earth titled Recycling of E-Waste in India and Its Potential, in which the author says e-waste recycling is virtually nil in India, despite India being highly deficient in precious mineral resources. If this is the reality, then what is the point of speaking and writing articles about e-waste management and e-waste recycling? Why government is not implementing effective strategies? That is a question by
Okay,
Arjun.
that's a very valid point. Actually,
Could you
uh,
please exit your presentation window so we can see your face?
okay, so I will just stop share. Is it better?
Perfect, perfect.
Yeah.
Yes, go ahead.
So actually, what is happening at the government level? There are very few recycling companies in India. I have been fortunate as a consultant to most of them, and at Niti Aayog, what we discussed that there has to be a streamline, what we call plant has to be there that can just show others because it is a very novice technology for most of the people. So if people can really say, okay, I will just test up a first plant for you. If it works, then others will invest. So that is the problem. Most of the time, these companies complain that we don't get heterogeneous, means homogeneous material, because if your feed will change every time, your material will change, the plant will also fluctuate a lot, and it goes into the down investment. So that is why the recycling potential is very less. And in fact, the real picture in India is that the kabadiwalas are collecting all this material and they are giving it to few companies. So what e-waste registered recycler is, it ideally it is meant to recycle, but they are not doing any recycling. They are just acting as a collector, and then they are just shipping it with huge smart profits to Europe. Okay, that is why the recycling is very low in India. In fact, out of 5 operating plants, 3 are on the verge of closure. So that is the new scenario for India. But definitely it is going to come up for sure.
Okay, so I will also pick up one more question, additional question. It's also related to that point. Akhil Barua is asking the question from Assam.
Okay.
Laws to manage e-waste have been in place in India since 2011, mandating that only authorized dismantlers and recyclers collect the e-waste. E-waste management rules 2016 was enacted on October 2017, yet e-waste recycling doesn't happen here. Would you suggest government to buy back the e-waste so that they can recycle effectively?
Yes, very valid point. Thank you for asking. Just as lead acid batteries, whenever our scooter or car has a battery, let's say malfunctioning or its end of life, the person who will replace that battery, he will deduct some money or he will give you the money back. So if we have this policy of means buyback policy, even if it is suppose very less amount, still the recycling can be very active. So that policy has to be taken care. This is the mindset problem, in fact, not the government problem, because we all say, okay, jab tak chal raha hai chalne do. So that is the mindset of problem going on in India. And this is one of the key points which is already mentioned to the ministry, that is called MITI, Ministry of Information, Electronics, Technology, Information. Okay. So they are taking care of this part, how they can bring the buyback policy for lithium ion batteries also.
Yeah. Dr. Nikhil, there is a one question from Mehru Malik.
Okay.
Is biochemical extraction of metals from e-waste a commercially viable process?
Not for e-waste right now, it is not being practiced, but for primary copper ores, I have visited that plant in Finland. They are doing it at minus 40 degrees Celsius from bacteria. It is going commercially very well because the cost of investment is quite low. Okay. But for e-waste, still it is not being practiced on industrial scale, but for primary ores, it is a proven fact, it can be workable. In Madhya Pradesh also there is one plant coming up for primary copper ores, not for waste.
Yeah. Thank you, sir.
Yeah.
Now there is one question from Saurav Banerjee. Is there
Okay.
any scope for in situ nanoparticle industry by using e-waste?
Uh, in fact, in situ nano waste particle generation can be there once you have all the metals in the solution form. Okay. Then based on recovering from solution, you can control the size of the metal particles, which it can be electro deposited. So that way there is an option for that.
Yeah. Now over to Dr. Felix.
Okay, so here is a question by Devendra Mudgil.
Okay.
It's asking why India bring e-waste from developed countries to dump here, knowing the problem associated with it. What are the government rules regarding this?
See, in fact, China and India are, let's say, probably getting this raw material from long time, not from 1 year or 2 year. It has been decades now, very well placed. So the incentive for them was that if you look at the Indian registered recycler e-waste companies, each state there are at least, for example, in Uttarakhand, I know there are almost 67 registered recyclers, whereas in Delhi, Bombay, Bengaluru, they are more than 200. So these companies were given the license by Ministry of Environment, Forest, Climate Change in the prospect that they will recycle. So that is why they are getting more and more material. But they are not doing. They are just segregating it from best of the lot policy. They are looking at that, getting the, for example, they always say, okay, you want high grade PCB, low grade PCB. Low grade PCB is your TV remote PCB. High grade PCB is your laptop PCB. So this is what they are doing, and they are getting benefit, and they are doing it. Government is aware of that, that okay, this type of wrong activities are going, but it will take a lot of time. Now recently there is a what we call recycling society is coming up in Andhra Pradesh. Professor B.S. Murthy, the director of IIT Hyderabad, is coming up with that committee to modulate some of the regular formulations for that. So it is going up. Okay, from last 1.5 year I am saying lot of work is going on, and I feel by 2025 it will be a new way for India also.
Yeah. Sir, I want to ask the question by Dr. Sunil Sahani. Is
Okay.
there any chemical or other method to detect e-waste contamination in water at home?
Uh, I think it is very difficult to answer. Means for water, generally there are standard water quality tests available for contamination of e-waste.
Yeah.
But unless and until they are in their good shape, we expect that nothing is going to contaminate in our household. But if they are being disposed of in the land for a huge amount of time, more than 5 years, then do you expect some metal penetration into that stream?
Over to Dr. Felix.
So let me pick one question here. Jayanta Kalai is asking, planned obsolescence by electronic companies is a major reason for generating e-waste. How can we, as well as the companies, root out this issue? It's a very interesting question, and I never knew what this obsolescence means. I searched out the word meaning, the process of becoming obsolete. That is
Yeah.
obsolescence. So planned obsolescence by the electronic companies. So what is your take on this?
See, actually, if you talk about first of all government system, the government says something becomes obsolete if its real value falls off, right? With every 10 years, the value is going to fall by percentage of 50, okay, or one by two. Now, if your service cost is more than its purchase cost at the time of purchase, means suppose you bought it 10 years back, suppose 100. Now the service cost is 101. Government will say declare it as obsolete. This is what government will follow. So this depends upon organization to organization. Some people very well foresee that okay, now this device is not going to be useful. Example, CRTs. Initially everybody said okay, why don't you donate the CRTs to NGOs? But again it is going to be again, let's say it will be just occupying your land. It is not going to be used. So it depends upon industry to industry. Sometimes some industry do it very well, but I know most of the private companies, for example, they have very well plans with recycling companies, just for not for the data management, but for the disk fragmentation also, and for some commercial value also. So there is buyback policy available with most of the companies these days.
Yes, sir. There is one question from Vinit Kumar Sahu.
Okay.
How can mishaps with e-waste, such as Mayapuri radiological incidents, be prevented in the future?
Can you please repeat? There is some echo in the voice.
Yeah, Chilli going. Yeah. How can mishaps with e-waste, such as Mayapuri radiological incidents, be prevented in the future?
Mayapuri e-waste incidents, right?
Yeah. Radiological incident.
Yeah.
Yeah.
See, for example, as I talked to you about rare earth elements generally, if you are talking about the primary sources, it falls under the atomic agency. You cannot touch it. Okay. For example, uranium and thorium comes along with it. So there are well guidelines available for that. If you are under that particular zone, you have to make sure you have very strong detectors for that, you can and means and cache those elements. Okay, this is this area. very simple example, if you go for any kind of, let's say, ultrasound or x-ray, they will always say a person who is having a pacemaker is not allowed to go in that space, right? Even if it goes, the machine will say boom boom, it cannot allow you. So there are sensors are available for that, so plant should definitely go with plenty of metal sorting sensors for that, so that they can pre-plan it. Okay, otherwise there is no option, because if you put multiple material, the failures are bound to happen. So only way is that you have to have more and more sensor or automation policies for that.
Yeah. Over to Dr. Felix.
Okay, so here is a question by where is that? The question is Takahashi Masako from Japan is asking a question. Here in Japan, we have to pay to dispose e-waste. We cannot simply trash. Why not India implement such a policy? Because disposing the e-waste is a costly affair.
See, as I explained in these slides, for Switzerland and for Japan, the policies are very strict. But for India, it is not the same, because you have to also realize that this is a mindset problem which is not going to be solved in few years. It is being carried over from years and years. Government is well aware about these facts, and the talks are going on with these leading electronics companies that can you even put a buyback policy, but most of them always says okay that the price will be enhanced by a factor of 10%. So the if it is a again burden on the customer, nobody is going to, unless and until all companies are agreeing, this particular policy will not come up. So that has to be there.
Yeah. So there is a one question from Anusua Nagaraj.
Okay.
Nowadays, there are some herbs are used for, and they will act as good absorbents for metals. Currently, is there any report on these herbs being used for e-waste removal?
Uh, Not for e-waste, but I understand the context of the question that herbs can be used for metal absorption or not. In fact, this has strong historical roots, and I am part of that. There is what we call Ayush Ministry. In fact, we are propagating that in mercury is a boon for Ayurveda, because it makes complexes with gold and you can get easily out of that. So that is why people are also thinking that okay, for cadmium, lead, tin, these herbs may be used, okay, or part of them can be used. But based on my observation, this is only on the academic side, not on the industrial side. So probably it will come probably 5 to 10 years, but that's a very valid point.
Dr. Felix, now over to Dr. Felix.
Yes, Dr. Rishmita from Gujarat is asking a question. Having lived in US for many years, certified refurbished electronics is very popular there. However, in India, such second-hand electronic products are not popular despite India being a developing country. Is our fascination with new and trendy gadget to blame for our EVs problem?
Yes, I feel so, but it is not that it is not coming up in India. Apple is offering that. Dell is also coming up with that. I'm aware of HP also. So slowly it is coming up in India also. But the only issue with refurbishment is the certification. If you get a very good certification, everybody will be happy to buy it. So that part is lacking in India in some of the companies, leading companies. So once it comes up, I feel there will not be problem. And yes, the as you can see, the lifespan of these devices is not more than a decade, right? For even for our personal laptops also, we feel that okay, within a span of 4 to 5 years, it is about to go. So yes, refurbishment can also solve the e-waste problem, but up to some extent, 25% or 30, but not completely.
So there is a one question from Dr. Deepti Sankat. She is
Okay.
asking to what extent the people engaged in e-waste recycling process are exposed to carcinogenic substances, or are there some safe ways?
Yes, very valid point. Uh, if you are involved in formal recycling plants, I will say the pyrometallurgy, hydrometallurgy, physical processing, the chances are probably less than 1%. But if you are involved in informal recycling, the number can be reversed, 99 probably. Okay, so it depends upon which recycling technique we are talking about. as of now means from my home place at 8 kilometers there is a recycling plant. So I am looking at that plant from last 7 to 8 years, and there has not been a single casualty based on these facts from carcinogenic point of view, or nor they have been detected any health problem. So this is a well-established thing. Proper medical are being done every yearly to record their different metallic contents as well as levels. What is going on? So that is not the problem for most of the formal recyclers.
Okay, so here is a question from Rahil Datta. It's kind of already covered, but still, why are we not following biomining for recovery of metals from e-waste, which are environmentally friendly processes?
Very good question. See, biomining or what we call bioleaching, it is a very specified technique and it does not work with all the metals. For example, for iron, since it occurs in multiple oxidation states like ferric and ferrous, it behaves very well. For copper, yes, the redox potential as well as based on those solution chemistry, it works very well. Now in e-waste, if I'm talking about, there are 26 elements in generally in PCBs. So how you can take care of 26 elements with a single bacteria? And for each element, if you go on for different bacteria and the thermal conditions, it becomes very difficult. Okay, so only thing is once you have some type of sorting, upgradation, concentration of some metals like copper, gold, silver, then you can go for it. But these people generally look at one board as a board, not as a small pieces. So that is why I think there is a challenge in that.
Yeah. So there is one question from Ram Deepak.
Okay.
To what extent phytoremediation can be incorporated to combat e-waste?
Uh, I feel it can be taken care well, but see, all these are very smart alternatives, but they will only and only work provided there is a well set up plant, right? We try to optimize or we try to check the alternatives once there is a well established process. India is in very nascent stage and we are struggling a lot, I will say, to find up such a process which can be robust. And the prime reason is the material composition. It changes every day, means for the plants. So but this alternative can come up in the means pathway of, let's say, once a process is established, then they will just see on different alternatives for that. So I will say it is not counted out, it can be counted in the passage of time, not at present scenario.
Over
Okay,
to Dr.
so here is a question by Dr. Sarbini Roy from Dehradun. She's asking, what are your advice for a commoner to recycle e-waste? If I have a broken phone or washing machine, which I cannot sell anywhere, what should I do?
So what you should do, you should look at the Uttarakhand website, government website. There are registered e-waste recyclers. You can contact them. You can say, okay, I want to discard your material, or I want to discard my the cell phone, etc. to you. So you can, and they will give you a certification that yes, they will do recycling, or what will be the ultimate part of that. Second option is that you can look for electronic bin if it is established in Dehradun. I am aware of Chandigarh. There are different sectors in which these bins are there. So generally, people dump their material over there. If nothing works out, you are means most welcome to send me an email. I can help you out on that where it can be done.
One more question. It is from Sarbini. Sarbini is asking a question. Again, her question is that she is a engineering student and she would like to know how to pursue a career in e-waste management. So, what are the degrees should I target for? And yeah, so what is your point about it, some
Yeah.
advice for the
Yeah.
upcoming
So
students?
yeah, I feel this is probably a very good blend of what we call interdisciplinary departments, because there is physics, there is chemistry, there is biosciences, life sciences, everything is there. So but the key word for this type of work will be environmental. So you should definitely look for a degree in environmental part, and then try to cover up many courses. It can be 1 year, 2 year courses followed by some very particular research. I know people who are working in only environmental management. They are working very well. They are doing very well, and there are plenty of opportunities throughout the world for this field. So it's a very good multi-fit stream, what I feel. So you can go for anywhere with a specialized degree, not for a broader degree in this case. If you want to go for that environmental, or even I will say a biotechnologies is a good fit. If you look about the biomining or bioremediation part for this one. So it is depending upon your interest, you can pursue. I feel options are plenty.
There is another related question from Soumyasti. She's asking like, she would like to do the internship in this area. So would you recommend some companies who are actually doing a good job in e-waste management, as well as any other established academicians? That is her question.
So there is a one company e-Parisara in Bengaluru. Then there is one company Atero in Bhagwanpur, Uttarakhand. Then Bharat Petroleum Corporation Limited, they are also very much interested in setting up EVs. So their group at this, particularly Ghaziabad, is very strong in that one. Then next case will be Sublime, a company in called Vadodara. Then is Rubamin Private Limited again in Ahmedabad. And for academicians, I can say I am also doing some work onto it. Even IIT Kharagpur is having some options. And then Hindalco, a company which is well established for aluminium. And generally these ones, not much, but there. And if you want to do foreign internship, probably there are n number of places I can mention you. The work is even going in Berkeley, Stanford. There is a consortium in Europe, between Europe as well as North America. So plenty of researchers are there. So please feel free to ask me anything if you want. Any of the student or any person, I am more than happy to help.
Just one more question. Vineet Kumar Sahu is an engineering student. He is asking that what are the textbook on this textbook or other valid references on this subject? So again, that is a academy related question. So still,
Yeah,
any good
yeah,
reference?
very good. There are only two textbooks on e-waste. Okay. So I can share the details with you. You can just send me an email. Only two textbooks, but that is only up to 2014 and 15, not beyond that.
I think it's high time for revising those textbook and releasing because the field is really pertinent. So
Yes.
yeah, perhaps somebody has to volunteer for this. Very nice session. I'm really happy that so many good questions have come up, and yeah, the discussions were really productive. Over to Dr. Kriti.
Yeah, thank you, sir. It's a great privilege for us to have you to this zero waste space, and you talk about the that e-waste and how to manage all these things.
Yes. Thank you. Thank you so much for giving an opportunity.
Over to Dr. Khalid.
Yeah, we are really happy to have you here, Dr. Nikhil, from the Inyas family, and it's really wonderful. And I like the way you presented and interacted because that is what the gene of science communication in you, just like any other Inyas member. So I'm really happy to be with you. You have spent 1 hour with us, and thank you. My best wishes. You are doing a fantastic job in IIT Roorkee, and yeah, my best wishes, and thank you so much for. We are really humbled to have you here.
Yeah. Thank you. Thank you for your kind words. Thank you. Thanks a lot.
Now moving to the next session. Our next talk is at 3:30 p.m. by Dr. Felix Past. So please stay tuned and enjoy your lunch. Have a nice lunch break.